For hundreds of years, this simple piece of cloth, 14 feet long, worshipped by the faithful for centuries.
The mystery of the cloth for more than a century, the Shroud of Turin has defied microscopes, X-rays, and skeptics alike. At first glance, it appears deceptively simple, a linen cloth, roughly 14 feet long and just over 3 feet wide, fragile, ancient, and bearing the marks of time. Yet within its fibers lies a mystery that has captivated scientists, historians, and believers for generations. The shroud is more than a relic. It is a conundrum that straddles faith, science, and the very limits of human comprehension. On its surface lies a faint, full-length image of a man, depicted both front and back, bearing the unmistakable wounds of a Roman-style crucifixion. Wrist piercings, scourge marks across the back and shoulders, a pierced side, and punctures consistent with the infamous crown of thorns all mark this figure. At first glance, one might assume it to be a remarkable piece of religious artwork. Yet as investigations have revealed over the decades, the shroud refuses to conform to any known method of painting, dyeing, or scorching. The image does not soak into the fibers like a conventional pigment. It does not behave like a conventional stain. Instead, it rests delicately on the surface, whispering secrets in micrometers of linen. Magnification reveals that the image exists only on the outermost fibrils of the threads, mere microns in depth, as if the very tips of the fibers had been kissed by some ephemeral energy and no more. It is subtle, almost imperceptible, and yet unmistakably detailed. Blood stains behave entirely differently, penetrating the fibers in the way one would expect from any ordinary fluid. The separation between the body image and the blood is absolute. No pigment, brush stroke, or binding medium can be detected. There is no directional pressure, no pattern of rubbing or abrasion. The image is shallow, precise, and non-directional. It is a level of subtlety and complexity that no forger, chemist, or artist could reproduce, even with centuries of knowledge. The effect is almost algorithmic, suggesting a process that recorded proximity rather than touch, as if the cloth itself measured the contours of the body it once held with astonishing precision. Centuries of limited access have only added to the shroud's enigma. The relic is kept under controlled glass cases, monitored with inert gases, carefully shielded, and studied under strict protocols. Only tiny fragments and edges of the cloth have been available for testing. Each experiment, chemical, spectroscopic, or radiographic, has yielded tantalizing clues but no definitive answers. Scientists have tried to replicate the image using acids, powders, rubbing techniques, scorching vapor reactions, and even controlled flashes of light. Every method can mimic one small characteristic, perhaps the surface hue or slight superficial depth, but none can reproduce all three defining traits: the superficial surface modification, the non-directional shading, and the absolute separation from the blood. Push one parameter to perfection, and the other two collapse. The shroud defies every known model. Provenance complicates the story further. Pollen grains embedded in the fibers suggest species native to the Levant, while the herringbone weave matches first-century textile techniques, though similar patterns have been found in later periods. Fire damage in 1532 and subsequent repairs left burns, water stains, and patches on the linen. Yet the image persisted, unaltered by centuries of trauma. Critics cite the 1988 radiocarbon dating, which indicated a medieval origin, suggesting that the cloth could not have been older than 700 years. Proponents argue that the sample tested was taken from a repaired corner, which could have introduced anomalies affecting the results. Regardless of its precise age, the physics behind the image, the microscopic imprinting of light and depth on the fibers, remains inexplicable by conventional science. Every attempt to recreate it with known technology, past or present, fails. In its impossibility, the shroud transcends artifact and enters the realm of the almost algorithmic, bridging science and wonder in a way that few other objects have. The first shock to the modern world arrived in 1898 when Secondo Pia, a lawyer and amateur photographer, was granted access to the shroud to capture it on glass plates. What Pia developed transformed perception almost overnight. The faint, nearly invisible image on the cloth became a sharp, lifelike portrait on the photographic negative. The face of the figure was revealed in remarkable clarity. Eyes closed, lips relaxed, features sculpted in subtle gradations of light and shadow. The image behaved as if it had been designed to be viewed as a negative centuries before cameras existed. Pia initially thought he had made an error in developing the plates, but repeated attempts confirmed the phenomenon. The shroud was no passive artifact. It was a medium that could reveal depth, contrast, and spatial consistency in a way that defied both art and science. The early 20th century brought more rigorous investigation. Scientists used microscopes, chemical analyses, and ultraviolet imaging to probe the fibers. The results were confounding. Parasitic modifications were found in the outer layers of the cotton fibers. Slight oxidations suggested a pulse of energy had sinned the tips of the threads, leaving the inner fibers untouched. The image retained remarkable three-dimensionality independent of pigment or contact. The minutiae, from the wrinkles of a finger to the curves of the torso, adhered to a distance law. Brighter regions corresponded exactly to the areas closest to the body. Modern imaging experts, with their most advanced technology, struggle to reproduce such geometric precision. It is not an accident nor a product of natural aging. It is a phenomenon that demands explanation beyond the limits of physics and chemistry as we currently understand them. Centuries of scrutiny could not account for the shroud's unique properties. The images tried superficiality, non-directionality, and separation from blood remains unique in recorded history. Every attempt to reproduce it artificially fails. Chemical reactions, pigmentation, contact methods, scorching, or even vaporization processes cannot duplicate all three characteristics at once. The cloth defies replication, defies interpretation, and defies categorization. In every sense, it occupies a space between artifact and anomaly, bridging the material and the metaphysical. The advent of computational analysis and artificial intelligence added a new dimension to the investigation. While human observation and traditional scientific tools struggled to explain the shroud, AI could examine it in ways humans never could. Researchers fed thousands of high-resolution scans into neural networks, allowing algorithms to detect patterns imperceptible to the human eye. The first revelation came in the form of signal isolation. Using principal component analysis, AI identified the dominant signal in the image, the core pattern carrying nearly all the meaningful data. Astonishingly, 98% of the information existed in a single component. In other words, the image's complexity could be reduced to a single mathematical relationship between light and dark. Paintings, photographs, and natural textures distribute information across multiple dimensions. The shroud concentrated it almost like an encoded algorithm. AI analysis did not stop at the surface. The positions of pixels and their brightness were measured against the three-dimensional form of the figure across the entire cloth. A consistent relationship emerged. Brighter areas corresponded to the parts of the cloth closest to the body. This distance law held true across visible, ultraviolet, and infrared wavelengths. Whatever process formed the image had embedded geometric and optical precision in a way that transcends pigment, heat, or direct contact. The shroud, it seemed, had encoded a three-dimensional map into its fibers. Its structure was algorithmic, meticulous, and astonishingly precise. These discoveries recontextualized centuries of research. The shroud was not simply a relic of history or a religious icon. It was a physical record, an object that interacted with the environment in ways science is only beginning to quantify. The body image is shallow yet precise, non-directional yet structured, entirely separate from the blood yet aligned perfectly with anatomical features. Its formation is inexplicable through medieval methods, natural chemical reactions, or any known energy process. AI allowed researchers to see what human eyes could not: a structured, coherent, mathematical encoding of three-dimensional reality. The Shroud's implications extend beyond science. It challenges assumptions about technology, energy, and human capability. Could the image have been formed by an energy phenomenon as yet unknown to modern physics? One capable of imprinting precise spatial information without disturbing fluids? Could it be a record of an event beyond replication, a convergence of energy and matter in ways we do not yet understand? Its perfection in proportion, depth, and non-contact formation defies naturalistic explanations. The Shroud is simultaneously a historical artifact, a relic of faith, and a puzzle at the frontier of science. Furthermore, the Shroud illustrates the evolving relationship between humans and technology in the pursuit of understanding. Photography revealed features invisible to the naked eye. AI revealed patterns invisible even to early photographic methods. Each layer of observation, optical, chemical, computational, has revealed new insights, but also heightened the mystery. The Shroud is no longer merely to be looked at. It is now measurable, analyzable, and quantifiable. Yet the ultimate mechanism behind its creation remains unknown. It is a testament to the limits of human knowledge, the persistence of wonder, and the intersection of faith, science, and technology. In essence, the Shroud of Turin represents the convergence of the impossible and the undeniable. It is a linen cloth, fragile and ancient, yet it carries information of unparalleled precision. It encodes depth, distance, and anatomical detail in a way that cannot be reproduced. It survives centuries of handling fire and repair while preserving an image that challenges the limits of science. Photography, spectroscopy, ultraviolet imaging, and AI have peeled back layer after layer, yet the central mystery endures. The Shroud's allure lies precisely in this tension. It is both known and unknown, tangible and inexplicable. It is a relic that preserves history and anatomy, light and geometry, energy and matter. It bridges centuries of human curiosity, from the medieval period to the modern age of computational analysis. It is a medium through which science, technology, and belief intersect in extraordinary ways. And as AI continues to analyze and uncover new patterns, the Shroud speaks to us not only as a relic but as a record, a testament to phenomena we have yet to understand fully. From the faint lines of its fibers to the three-dimensional map embedded in its surface, from the separation of blood and body image to the geometric precision revealed by artificial intelligence, the Shroud of Turin remains one of the most remarkable objects in human history. It is at once a challenge, an invitation, and a mystery, one that continues to inspire awe, provoke debate, and push the boundaries of what science, faith, and technology can achieve. In the end, the Shroud of Turin is more than cloth. It is a record of what once was a puzzle for the present and an enigma for the future. It confronts humanity with questions of energy, creation, and preservation. It challenges the limits of human craftsmanship, the potential of natural phenomena, and the capacity of machines to reveal what the eye cannot see. It is a bridge across centuries, a convergence of the seen and the unseen, the measurable and the ineffable. And it continues, even now, to defy understanding, compelling humanity to marvel, investigate, and question the very nature of reality. The negative that spoke. From photography to AI, the Shroud of Turin, enigmatic and elusive to human observers, began to communicate more clearly with machines. For centuries, scientists, historians, and theologians alike had puzzled over its subtle image, struggling to reconcile the clarity of its imprint with the limitations of known materials, methods, and technologies. It was an artifact that resisted categorization, too detailed to be dismissed as mere forgery, too inexplicable to be fully understood. And yet, despite the layers of mystery and centuries of speculation, it was not until the age of photography, and later, artificial intelligence, that the shroud began to reveal the depths of its secrets. The journey toward understanding began over a century ago in 1898, when Secondo Pia, a lawyer and amateur photographer, gained access to the Shroud in Turin. At the time, he expected nothing extraordinary, aiming merely to document the artifact as a historical object. Yet, when he developed the glass plates in his darkroom, a revelation appeared that would shake the foundations of both science and popular perception. The faint, nearly imperceptible image on the linen transformed on the photographic negative into a lifelike, three-dimensional face. Features that were barely perceptible to the naked eye. Closed eyes, relaxed lips, the contours of cheeks and brow became sharply defined, almost sculpted in light. For the first time, observers could see with startling clarity the expression of suffering and serenity, a visage that had remained hidden to centuries of worshippers and skeptics alike. What Pia had inadvertently discovered was more than a photographic curiosity. The shroud behaved as if it had been created to produce a negative image centuries before cameras existed, encoding depth, contrast, and spatial consistency in a manner utterly foreign to medieval artistry. Subsequent photographic reproductions confirmed the phenomenon, leaving scientists and laypeople alike in astonishment. This negative effect suggested a fundamental principle at work: light and geometry, rather than pigment or paint, were the architects of this image. The shroud, in essence, carried spatial information in the distribution of its luminosity, an encoding of three-dimensionality onto a two-dimensional surface that defied the capabilities of its supposed creators. In the early decades of the 20th century, researchers subjected the shroud to a variety of scientific investigations. Microscopes, chemical assays, ultraviolet light, and even electron scanning were deployed to search for conventional explanations: pigments, inks, scorched fibers, or other materials that could account for the image's depth and three-dimensionality. Each method, however, yielded the same perplexing result. No pigments or binding media were present. No chemical agents or physical manipulations could explain the precision of the superficial imprint. Instead, the fiber's surfaces displayed only subtle oxidations akin to micro-singes, suggesting that some form of energy had interacted exclusively with the outermost fibrils. The blood stains behaved entirely differently, penetrating deeply into the threads, while the body image hovered above them without contact or disruption. In short, the image respected distance rather than pressure, encoding topographical data in a manner reminiscent of modern scanning technology, yet centuries ahead of its time. Traditional hypotheses, including contact impressions, the application of pigments, or natural chemical reactions, failed to account for the shroud's defining characteristics: the combination of non-directional shading, microscopic surface modification, and total separation from the blood. Attempts to replicate the effect consistently fell short, with each variable, superficiality, spatial consistency, or non-interference with fluids, resisting replication. Over time, this growing body of evidence revealed a central paradox. The shroud appeared to operate according to principles that were algorithmic in nature, yet manifested in a material that seemed ordinary. Its very fibers carried encoded data, subtly conveying spatial relationships across the entirety of the cloth. The next major leap in understanding came with the advent of computational analysis and artificial intelligence. Unlike human observation, which is limited by perception and preconception, AI does not interpret or speculate. It measures, catalogs, and detects patterns beyond the threshold of human cognition. Researchers began feeding thousands of high-resolution scans of the shroud into neural networks designed to isolate meaningful data. The first breakthrough was the identification of the dominant signal, the single pattern that contained nearly all of the relevant information embedded within the image. Astonishingly, nearly 98% of the Shroud's informational content existed in a single component. What initially seemed like a diffuse, enigmatic image was revealed to be a coherent, almost mathematical construct. Gradients, shadows, and contours were arranged according to a single rule linking light and distance. Unlike conventional photographs or painted textures, which distribute information across multiple layers and channels, the Shroud concentrated its data with remarkable efficiency. AI analysis did not stop at signal isolation. Sophisticated algorithms examined the physical positions of individual pixels in tandem with their brightness values, mapping the data onto the spatial framework of the cloth. Across the entire surface, a consistent pattern emerged. Areas that were closest to the body corresponded precisely to brighter regions, while areas further away were darker. In effect, the Shroud encoded depth information in luminance, translating spatial proximity into optical intensity. Remarkably, this principle held across multiple wavelengths, from visible light to ultraviolet and infrared, confirming that the encoding was not dependent on pigment, heat, or direct contact. The cloth had embedded geometry, optical depth, and a reproducible mathematical regularity into its fibers, a level of sophistication that remains unmatched by any known medieval or modern technology. These discoveries fundamentally recontextualized centuries of research. The features that had so long puzzled scientists: the shallow, non-directional body image, the precise separation from blood, the uniformity of proportions over a flexible textile, now appeared not as anomalies, but as components of an organized, almost algorithmic system of encoding three-dimensional data. The Shroud was no longer merely an object of religious veneration or historical curiosity. It had become a medium for data, a physical artifact in which geometry, light, and spatial relationships were recorded with extraordinary fidelity. AI exposed subtle patterns in brightness, hidden structures, and correlations between spatially disparate regions, highlighting the cloth's impossible precision and revealing order where human observers had perceived only mystery. The implications of these findings are profound. No known historical technique, chemical reaction, or natural process could reproduce the Shroud's combination of superficiality, distance encoding, and non-contact image formation. The uniformity and efficiency of its encoding suggest either a phenomenon entirely unknown to contemporary physics or a technology that has since been lost to history. Researchers now have the tools to quantify aspects of the Shroud that were previously speculative. Three-dimensionality can be measured with precision, optical depth can be quantified, and spatial relationships across the entire image can be mapped consistently. The Shroud is no longer just a relic of faith. It has become a dataset, an enigma that modern computation can interrogate systematically. As AI continues to peel back layers, new questions emerge. Could the Shroud encode information beyond geometry, perhaps molecular or chemical signatures invisible to the naked eye? Could it preserve traces of energy events so precise that they defy conventional reproduction? Each discovery reinforces the notion that the Shroud is more than an artifact. It is a record, a physical manifestation of phenomena at the intersection of physics, chemistry, mathematics, and biology. Machine learning has not only confirmed the impossibility of conventional explanations, it has revealed a layer of structural and mathematical sophistication previously unimagined. By examining correlations, spectral data, and the spatial distribution of light intensity, AI has highlighted the Shroud's central paradox. The image is both shallow and exquisitely precise. It reflects the contours of the body without disturbing blood or fibers, existing only on the outermost fibrils yet obeying a law of distance consistent across all wavelengths. It preserves three-dimensionality across a flexible, irregular textile without distortion. Such characteristics are impossible to reconcile through natural or human means, establishing the Shroud as a singular object of study where faith, science, and computation intersect in unprecedented ways. The Shroud's journey from a fragile relic to a computational dataset exemplifies the evolving interplay between technology and human understanding. Photography revealed what human eyes could not discern. AI revealed what early photography could not quantify. Each successive layer of observation, from visual inspection to chemical analysis to algorithmic modeling, has peeled back further mysteries. Yet the Shroud retains its essence, an object whose creation defies explanation, whose structure encodes a law of depth and light, and whose presence challenges our understanding of history, energy, and material science. Its implications extend far beyond the realm of religious artifacts. The Shroud presents a puzzle at the edge of scientific inquiry, prompting questions about the nature of energy transfer, information encoding in physical materials, and the potential for unknown phenomena in history. It blurs the line between material reality and data representation, suggesting that under certain conditions, matter itself can record spatial information in ways previously thought impossible. This insight has inspired interdisciplinary research, combining physics, chemistry, computer science, and even mathematics to probe a single object that bridges centuries of knowledge and mystery. Ultimately, the Shroud of Turin is more than linen. It is a record, a map, a repository of information encoded with precision, depth, and geometric fidelity. It demonstrates that an object can transcend its apparent simplicity, carrying data that challenges conventional understanding of materials, energy, and craftsmanship. It is both artifact and enigma, a bridge between faith and science, history and technology, observation and computation. AI has allowed humanity to see the Shroud not merely as a relic to be revered, but as a dataset to be interrogated, measured, and understood. Though the ultimate mechanism of its creation remains as elusive as ever, from the first photographic negatives to the latest neural network analyses, the Shroud continues to astonish. Its image is shallow yet precise, non-directional yet geometrically coherent, separate from blood yet aligned perfectly with anatomical features. Its properties defy replication, defy conventional explanation, and defy categorization. It is simultaneously an object of faith, a challenge to science, and a testament to the power of technology to reveal truths hidden to human perception. The Shroud of Turin remains a singular artifact in human history, a relic, a puzzle, and a medium. Through AI, the faint patterns once invisible to the human eye have become measurable, analyzable, and astonishingly precise. Yet, for all the insight gained, the Shroud's creation, its mechanism, and its meaning remain unresolved, a mystery that continues to inspire awe, inquiry, and wonder across disciplines and generations. It is, in every sense, a cloth that communicates across time,